Hola a todos, my name is Natalie Loarca, and I'm a Prime Pre-Health Pathways Scholar and a Biological Science major here at UC Irvine. I conduct my research in the Nicholas Lab under the mentorship of Dr. Duquina Nicholas, where our focus is on understanding immune mechanisms in type 2 diabetes. Today, I will be sharing my project, which explores CD1A as a novel marker of immune activation in the pancreas. What I really want to know is how does CD1A expression in the pancreatic tissue differ between type 2 diabetes patients and healthy controls, and what this actually reveals about immune activation in later stages of the disease. Before I was even born, my abuelito was diagnosed with type 2 diabetes. For him, treatment meant insulin injections, glucose checks, and oral medications. But what was missing was education. He was never taught how to eat better, how lifestyle shaped his health, or how to manage his disease day to day. Like so many families in underserved communities, my family carried this burden in silence. His story is one of the many millions, and it motivates me to search for better answers. Why should we study type 2 diabetes? Type 2 diabetes affects 1 in 10 adults worldwide and disproportionately impacts low income and Hispanic communities. We already know that inflammation plays a major role, but current research mostly uses broad markers like CD45, CD68, or CD3, which only tell us so much about general immune activity. What's missing is a much deeper understanding of how immune pathways inside the pancreas actually drive the disease forward. Why should we study the pancreas? Well, most studies focus on adipose tissue, but the pancreas is where the beta cell failure actually happens. By studying pancreatic tissue, we can see how immune cells cluster around the islets and directly contribute to disease progression. This perspective gives us a chance to study markers that haven't been explored before. Like I said before, my research question aims to ask how CD1A expression differs in type 2 diabetic pancreas compared to healthy controls, and what does this reveal about immune activation in later stages of the disease. In order to answer this question, I'm going to be investigating using H&E stained pancreatic slides and segmenting cells with Cell Profiler and Deep Cell, and then uploading these files into Histocat in order to map spatial patterns of immune activation. What should we expect to see? Well, in type 2 diabetic pancreas, we want to see an increased level of CD1A positive dendritic cells, specifically around the islets, while healthy pancreas should have little to no CD1A expression. If confirmed, this would suggest that CD1A is a novel biomarker of later stage pancreatic inflammation, something traditional markers haven't been able to reveal. Why is this important? Well, this could lead to new intervention strategies for patients already living with diabetes, guiding targeted therapies to slow disease progression and supporting more personalized care. Most importantly, these insights could help close the equity gap, offering better treatment options for communities like mine that carry the greatest burden of type 2 diabetes. Thank you so much for your time.